We're solving problem 14 from the 2020 F equals MA exam A. Two blocks of mass M are placed on top of each other, and the bottom block is placed on the ground. The ground is frictionless. The static and kinetic coefficients of friction between the two blocks are mu of S and mu of K, with mu of S is less than mu of K. The blocks are at rest initially. When a constant horizontal force F is then applied to the bottom block, which of the following graphs could show its acceleration as a function of F? The first thing to note in this case is that since there's two blocks, and if they don't slip, well then the force due to Newton's second law is 2ma. Therefore, we can solve for acceleration to get that a is F over 2m. In this case, we also have to consider friction. So for friction, friction is equal to simply ma, or half of that of force F. So this is F over 2. We know that friction is got to be less than mu of S n, static coefficient. So this is, and where normal force is simply mg. So we plug that in. F is less than mu of S mg. Since we know that friction is equal to force over half, we get that force over 2 is less than mu of S mg. So the force for static coefficient is less than 2 mu of S mg. Now we want to talk about the kinetic coefficient. So we get that for friction, this is equal to mu of K n, or mu of K mg. Thus, we can say that F minus, or force minus friction, since friction is F over 2, this will yield a result of F over 2, or ma. So we can, the whole point of this is to simplify. So we get the force minus friction here, which is mu of K mg. So mu of K mg, and this is again F force over 2, which is ma. In this case, we get the acceleration is F over m minus mu of K times g. In both of these cases where we have accelerations, this case we get that force is less than 2 mu of S mg, where in this one force is greater than 2 mu of K mg. So therefore, from these values of acceleration, we get that our answer for this problem is answer choice B.